We're going to look at the higher tier content for AQA, GCSE Physics and Unit P2, and in this video we're looking at calculating the acceleration from a velocity time graph using the gradient method, and we're going to look at how to calculate the distance travelled using a velocity time graph. Now, in a previous video we said that to calculate the acceleration you can use this formula here. A equals v minus u over t. So that's acceleration is final velocity minus initial velocity divided by t. If that's a little bit confusing, you can watch the previous video on how to do that. But for now, we're going to use the gradient method to calculate acceleration. So let's look at, for example, part C on this graph. Now, one way to work out the acceleration would be to use the formula. So the final velocity would be 40, take away the initial velocity, which is 20, and divide it by the time taken. But another way to do it would be to use the gradient. In actual fact, you get the same answer, but a slightly different way. So what we do is we, for the section we're interested in, so section C, we can draw a triangle like this, and then all you have to do is divide the vertical distance here over the horizontal distance here. So in this case we're going from 20 to 40, so the difference there is 20. So the distance between here and here is actually measured as 20, and between here and here we go from 15 to 20, so that's 5. So all you would do is put the 20 over 5, and that gives you an answer of 4. And remember, for acceleration it's 4 meters per second squared. Okay, so that's how you calculate the acceleration using the gradient method from a velocity time graph. You could, as practice, work it out for the different sections on the different parts of the graph from the notes if you download it from the website. Now, the second thing that you need to be able to do is to calculate the distance travelled. The distance travelled is the area under the graph. Okay, so if you calculated all the area underneath this graph, that would give you the distance travelled, and we could do it for various parts. So let's do it for this part here, which I think I previously called section B. But the distance travelled between 10 and 15 seconds, all you would do is you'd calculate the area, and the area for this shape here is simply given by the length times the width, okay, or just timesing two sides together. So from there to there we've got 10 to 15, so that's a distance of 5, and from there to there is 0 up to 20, and simply to calculate the distance for that section you would just multiply 5 by 20 equals 100, and as its distance it's meters. Now if you think about it, that kind of makes sense because we are travelling between 10 and 15 seconds, we are travelling at 20 meters per second for 5 seconds. So every second we travel 20 meters, so after 5 seconds it makes sense that we have travelled 100 meters, and that corresponds with the area under the graph here. Okay, a second place where we could work out distance travelled, where it's slightly more confusing, is say from 0 to 10 seconds. Now we haven't got a square here, we've got a triangle, and the formula for the area of a triangle is area is half of the base times height. And unfortunately they don't give you this formula in the exam. You'll have to remember it from your math lessons. Okay, so for part A, this section here, the distance travelled is half of the base times height, so that would be half of 10 times 20. Okay, so I'm using the base distance as 0 to 10, so that's 10, and the height as the velocity change from 0 to 20, so that's 20, and we can squeeze that in over here. So 10 times 20 is 200, and half of that is 100. So the distance travelled is just coincidentally 100 meters. So that's how you calculate the distance using a velocity time graph. The only other section that might be slightly complicated, I haven't actually seen this in an exam, but but might be worth looking at. If you wanted to work out a distance travelled between 15 and 20 seconds, you could just simply divide it into a square and a triangle, work out the areas individually and add them together. Okay, so that's how you work out the distance travelled from a velocity time graph and the acceleration.